So, hello everyone. This is Hymavathi, working as an assistant professor in the Department of Humanities and Science, MLR Institute of Technology. So, today in this session, we will discuss about the particular integral type 2 or method 2, and we'll solve one problem on the method 2 or the type 2. So, in the last session, we have seen the type 1 of the particular integral. This is the type 1. The type 1 of the particular integral is q of x is equal to e power ax. So, now we will see the problem on this also, that is a type 2. So, then what is the type 2 of a particular integral? So, the type 2 or the method 2 of a particular integral is q of x is equal to sin ax or cos ax. So, here a is a constant. So, we know that what is the yp? So, yp defines yp is equal to 1 by f of d into q of x is the yp, right. So, here the q of x is nothing but either sin ax or cos ax. If it is the sin ax, the same working rule, and cos ax is also the same working rule. So, what is the yp to find if q of x is these functions? So, replace d square by minus a square. So, where the a we have, so this is the a, this a you have to substitute in the place of d square by minus a square in f of d. If f of minus a square is not equal to 0, then the yp is 1 by f of minus a square sin ax or cos ax. Sometimes the failure case is also exist. So, if it fails, so then what we have to find the particular integral is x into 1 by f dash of minus a square. That means we have to do the differentiation on f of d with respect to x, with respect to d. Then after that you have to replace d square by minus a square. Not in the place of the d terms we are taking the substitution here. Only d square by minus a square, where f dash of minus a square is not equal to 0. Sometimes the first order derivative also 0 after replacing d square by minus a square. In that case, again you have to take x square into 1 by f double dash of minus a square into sin ax is the yp. So, where f double dash of a minus a square is not equal to 0. So, continue this procedure until getting the denominator is not equal to 0. So, now we will see the problem on this method, the when q of x is equal to sin ax or cos ax. Solve d square plus 3d plus 2 into y is equal to sin 3x. Is equal to sin 3x. So, see the question once here, the solve d square plus 3d plus 2 into y is equal to sin 3x. So, now this differential equation of the form f of d into y is equal to q of x. So, where q of x is here in the form of sin ax. So, if it is the form of a sin ax, so we have to use the type 2 or the method 2 of finding a particular integral. So, before going to find the particular integral, we have to find the complementary function first. So, now to find the complementary function. So, to find the complementary function, 1 by f of d, to find the complementary functions, we have to take the auxiliary equation. We have to take the auxiliary equation. So, that auxiliary equation is nothing but the algebraic equation of f of m is equal to 0. So, f of m is equal to 0. So, f of m is equal to 0 is, that means m square plus 3m plus 2 is equal to 0. Then now you have to get the roots. So, that roots we have to find out m square. So, this 3m can be taken as m plus 2m plus 2 is equal to 0. So in the first two terms, take m common, m into m plus 1 plus the next two terms, take 2 common, m plus 1 is equal to 0. Again take the common m plus 1 into m plus 2 is equal to 0. So now the roots are m is equal to minus 1 comma minus 2. So then now here the roots are real and different roots. So if the roots are real and different roots, the complementary function is c1 e power minus 1 into x is minus x plus c2 e power minus 2x. This is the complementary function. Now let's see how to find the particular integral when the function is sine 3x. So now see the particular integral. And to find the particular integral, it defines yp is equal to 1 by f of d into q of x. So we know what is f of d, d square plus 3d plus 2 into q of x is nothing but sine 3x. So in this, what is the substitution to take by the rule? So we have to take the substitution d square is equal to minus a square. So here the value of a is 3. Here a is equal to 3. The substitute d square is equal to minus 3 square. This is minus 3 square. This is not minus 3 whole square. So d square is equal to minus 9. We have to substitute. So 1 by d square value is minus 9 plus 3d plus 2 into sine 3x. So here we are substituting in the place of d square only, not in the place of a d. So that is the rule of a yp when q of x is equal to sine ax or the cos ax. So after the simplification, it gives 3d minus 7 into sine 3x. So by the rule 2, so what's the substitution we said? D square is equal to minus a square. But here we have the d term is there. But we required d square in the denominator again. Then what we have to do? By rationalizing, obviously the denominator is converts to the terms of d square. So what is the term? We have to multiply and divide with 3d plus 7. So 3d plus 7 into 3d minus 7 into sine 3x. Right? So 3d plus 7 whole divided by, this is of the form a plus b into a minus b. A plus b into a minus b is nothing but a square minus d square. So 3d whole square, that means 9d square minus 7 square. 7 sevens are 49 into sine 3x. Now in the denominator we have d square. Now again you have to replace d square is equal to minus 9. The same substitution we have to replace, that is d square is equal to minus 9. So 3d plus 7 into sine 3x divided by 9 into minus 9 minus 49. Right? So 3d, that means now in the numerator you have to multiply with the each term 3d sine 3x plus 7 into sine 3x whole divided by, so 9 9s are, we know that this is 81 minus 81 and minus 49. So minus 81 and minus 49 value is minus 130, right? So what is the d stands for? So d stands for the differentiation. So now we have to differentiate on sine 3x. So 3 into the derivative of sine 3x is nothing but 3 cos 3x plus 7 sine 3x whole divided by minus 130. So now we will simplify this. 3 3s are 9. 9 cos 3x plus 7 into sine 3x divided by minus 130. So this is the yp of the given differential equation where q of x is equal to sine 3x. So now finally we have to write a general solution. Then how can we write the general solution? The general solution is y is equal to yc plus yp. The general solution is y is equal to yc. So this is the yc, c1 e power minus x plus c2 e power minus 2x. Then coming to the yp plus, so before we have the minus is there, so we have to write the minus before, minus 1 by 130 into 9 cos 3x plus 7 sin 3x. Right? This is the general solution of the given differential equation. Suppose if q of x is equal to cos 3x is also the same process, either it should be sine of ax plus b or cos of ax plus b is also the same process. We can apply to find the particular integral when q of x is equal to sine ax or cos of ax plus b or sine of ax plus b. So then how can we find when q of x is equal to sine ax? What is the substitution to take? So d square is equal to minus a square. So in the place of the d square only we are taking the substitution, not in the terms of d. So if it is a d square term, we can substitute. If not, we have to use the rationalization and then you have to change to the terms of d square. Then later we have to substitute d square is equal to minus a square when q of x is equal to sine ax or cos of ax plus b or sine of ax plus b is also the same rule is applicable. So today in this session we discussed about the particular integral of type 2. In the next session we will discuss the type 3 of the yp. Yp is nothing but the particular integral. So that type 3 is nothing but a polynomial. So polynomial or x to the power k. So if it is x to the power k, then how can we find the particular integral? We will see in the next session. So thank you.